video is for my ISU portfolio for my grade 12 chemistry class, and it will comprise of me answering questions relating around the subjects that were taught to me during this course. So the four main units that were taught to us during this course were organic chemistry, structure and properties, energy changes and rates of reaction, and chemical systems and equilibrium. So in total, I will be solving 5 questions in this video, and 4 of these questions will be coming from the textbook or the PowerPoint slides provided to us during our lessons. The very last question will be from a quiz or test that I previously did. So the first 2 questions will be mathematical based. This first question is from lesson 5.2, calorimetry and enthalpy. This question states, a coffee cup calorimeter is filled with 200 milliliters of water at 22.1 degrees Celsius. A piece of metal at 48.6 degrees Celsius with a mass of 5.1 grams is added. The final temperature of the water in the calorimeter is 26.8 degrees Celsius. The density of water is 1 gram per milliliter, and its specific heat capacity is 4.18 joules per gram degree Celsius. Determine the specific heat capacity of the metal. In this question, I gathered all the information that was given and used it in the equation Q equals mc delta T. In this equation, Q represents the thermal energy in joules, M represents the mass of the substance, C represents the heat capacity of the substance, and delta T represents the temperature change this substance goes through. Once I found out the thermal energy of water, I used that thermal energy amount in order to solve for the specific heat capacity of the metal, as it would allow me to isolate for C. The specific heat capacity of the metal is 35 joules per gram degree Celsius. The second question is from 7.2 equilibrium law and the equilibrium constant. This question states, at equilibrium, the concentration of chlorine gas is 1.62 times 10 to the negative 1 mole per liter, and of fluorine gas is 1.85 times 10 to the negative 1 mole per liter. Calculate the equilibrium concentration of chlorine trifluoride gas. In this question, all I had to do was use the equilibrium law equation and sub in all its designated values into the equation. At the end, I was able to isolate for chlorine tetrafluoride gas. The next 2 questions will revolve around subject area connections. This means that these 2 questions will revolve around subjects other than chemistry. In this case, I chose 2 questions that relate to biology. The next question revolves around bond energies, and it states, in photosynthesis, a plant converts carbon dioxide and water to glucose and oxygen. Use the bond energies to estimate the amount of energy the sun provides per 1 mole of glucose. In order to solve this question, I will use a bond energy table in order to find how much energy is required for each bond. And I will also use the molecular structure of glucose in order to figure out how many bonds glucose has, since it's very complex. Once I figure out the bond energy for each bond and how many bonds are in photosynthesis, I will use those amounts to calculate the bond energies of the reactants and the bond energies of the products. From there, I will be able to find the enthalpy change by subtracting the energy of the reactants minus the energy of the products. The next question revolves around lesson 1.3, aromatic hydrocarbons. This question states, mothballs are small lumps of pesticides that discourage moths from damaging woolen clothing. The main component of mothballs is para-dichlorobenzene. What is the proper IUPAC name for this compound? Draw the structure of para-dichlorobenzene. In order to figure out the IUPAC name of para-dichlorobenzene, we must figure out which carbon is each substituent group on? In this case, the substituent groups are chlorine. Given the prefix para, we know that the substituent groups are placed on the first and fourth carbon. The last question is from quiz 4.1 to 4.5. This question asks us to draw a Lewis structure of bromine tetrafluoride and also predict its molecular shape and its polarity. The first thing I did was to calculate how many valence electrons this compound had. From there, I used this amount in order to create the shape of bromine tetrafluoride. Then I calculated the difference in electronegativities between bromine and fluoride. I found out that they had a difference of 1.02, meaning that their bonds are polar. The shape of this molecule is square planar, which is a symmetrical shape, making the entire molecule nonpolar. Overall, I think that my experience in grade 12 chemistry was quite positive. I think I learned a lot during grade 12 chemistry given the shortened amount of time, and I liked how there were several small quizzes rather than big tests so that we wouldn't have to fear about failing a quiz or two. I also liked how the workload wasn't too strenuous. There were never a time where I felt rushed in studying, and I felt like there was more of a focus on learning the information rather than just getting through the course. My future in chemistry will be through my biomedical science degree at Ryerson University, where I'll be working in a lab with chemicals in order to experiment on diseases, cells, and other things like that, and understand how the human body works.